My name is Olivia. I go to Community House Middle School. I'm in 7th grade, and my favorite thing about math is probably the teacher.
Oh, you like the teacher.
Yeah.
So you like Mr. Herb, huh?
Mm-hmm.
Yeah, he's a great teacher. Yeah, I like him too. Yeah. All right. I think for this specific assignment, we have 3 problems. Olivia, you did a wonderful job on problem number 3. Well, you're a perfect scorer, so you did all problems correctly. But problem number 3, you're probably the fastest one, and you are closest to the actual the real answer. Maybe yours is the real answer. It's the correct answer. So can I give you problem number 3 to explain your thought process about problem number 3?
Yeah.
Okay. Then let me start with problem 1 and 2. Okay. I only want to copy the first problem. Copy. Okay. So for problem 1, there were a few students who did it really fast, and got the correct answer really fast. So I want to see if Aaron Chen is here. Is Aaron here? If Aaron is not here, how about Raghav, Arun? Is Raghav here? Then how about Srinivas? Is Srinivas here?
Yes.
Okay, Srinivas, you are one of the fastest one to get this question correctly. Can you share with us your solution?
So first, basically what I did was I just tried to find numbers which are cubes and also squares. So the first number we have to start with, which is a cube, is 125. And then
Sorry,
the
say
only
it
other
again.
cube,
Say it again. What do you mean looking for numbers for cubes and squares?
because there has to be a number, because since s cubed has to equal a squared, cubed and a squared have to be the same number, so there has to be a number which is a cube and a square.
Okay, so you're looking for a number that is both cube and square.
Yeah.
Okay, keep going.
So then the first number that we start with is 125.
But 125 is not a square, right? 125 is a cube, but not a square.
Yeah. Yeah, the only number which is a cube and a square, which is between the range, which works, is only 729.
729. How did you get this number?
I just tried to find 5 cubes, 6 cubes, 7 cubes, 8 cubes, and then 9 cubes. And also I saw that since 720, to get 729, it's just 9 cubed, and it's, so it's like that. So what I noticed in 9 cubed was that it was 3 squared cubed, and that was 3 cubed squared.
Okay.
And there's no other number which works like that between the range. So 729 is the only number which works. So if you...
So is there a sequence that made you, reach to 729? How did you come up with this number? So yeah, once you know it's 729, yeah, you know it's 9 cubed and 27 square. But how did you get to 729? So let me get your thought process straight. So first of all, you try to see if 125 works, right?
Yeah.
What's your second step? This is your first step.
So since 125 doesn't work, but I tried to find how far away it is from that, being squared. And then I'm pretty sure there was a pattern until it got to 0. But then pattern never appeared again.
Okay.
So so the pattern, so from the pattern, it came to 0 at 7:29, and then it doesn't ever come to 0 again.
What is that 0 thing? What is the pattern?
So 125, if you try to find the square root of it,
Mm-hmm.
it's,
So square root of 125?
yes.
Okay. So this is 5
And that is,
times square root of 5?
yeah.
So how do you go from here to
um,
729? You want to, give it more thoughts?
Yeah.
Okay. So who else want to chime me some ideas? Any other idea? How do we get to 729? So by the way, the correct answer is 27. Okay, that number A is 27. That's the only one value. But how did we get to this 729 or 27? Anyone want to have a try? Just unmute yourself and announce your name. Okay, if nobody, then let me. Who's that?
David.
David, go ahead.
So starting with his solution. Wait, what's his name again?
Srinivas?
Yeah, starting with Serena's solution, looking for squares and cubes. So the squares and cubes from 1 to 18 are 64, 729, and
Okay, so you're saying
16
from
cubes.
1 to 18?
Cubed.
Okay, so you want to see the cubes from 1 to 18?
Yeah.
But you don't
And
need
then,
to go from 1, right? Because A is a 2-digit number.
yeah.
So all you need is start from 11, right? 11 cube to 18 cube.
Mm-hmm.
Why not 19?
19 because the largest sum of a two-digit number's digit is 18.
Yeah. Oh, I'm sorry. Yeah, you need to go from 1 because A could be 10. So it has to be, 1 cube to 18 cube. And the reason you don't need to try 19 or 20 is because if it's A is a 2-digit number, so the largest digits will be 9. So 9 plus 9, 9 plus 9 is 18. So all you need to see, check is from 1 cube to 18 cube. So you check all these cubes.
No, you can just, so n squared cubed that n cubed that n has to be a perfect square in order for it to be both a perfect square and a perfect cube.
So you have to find a perfect square. You need to find the base must be a perfect square, right?
Yeah.
So there has to be either 4 or 9 or 16, right?
Yeah. And
Or
so,
1.
yeah. One cube too small.
But 1 is too small. Yeah.
Yeah.
Okay.
4 cubed is 64.
4 cube is 64. And the square root of 64 is 8. That is also too small, right?
Yeah. And then you test 9 cubed, which is 729.
Okay, 729. And the square root of 729 is 27. This works.
And then 16 cubed is 4096.
4096. And the square root of it is
64.
Is
64.
Is what?
64.
64.
And the sum of 64 is 10. So that doesn't work.
10. This doesn't work. Okay. All right. So then 27 is the only one, right?
Yeah.
Okay. Cool.
I have an answer.
Okay. Another solution. Leo said he has another solution. Go ahead, Leo.
Well, if you know that s cubed equals a squared,
Uh-huh.
then the value of s cubed or the value of a squared must be a perfect, like 6th power.
Okay. So Leo said if s cubed equals a squared, all right? So then let's make this number is big N, okay? Then N must be a number, let's say m to the power of 6, all right?
Yeah.
Explain why is that?
Because like, well, if something to the, well, if you find something to the 6th power, cubic root, would be, well, you first, well, it's basically saying that, what's the least common, what's the, like, kind of like,
All right, let me give it a try here. Okay, so this observation is interesting, right? So if a number is something's cube and is also another number squared, then this number must be another number 6 power. Let's see if this is correct, okay? So if we have s, if we factorize s, this p1, p2, p3, all these prime factors, okay, prime factors. And there could be, p1 to the something power, p2 to the another, a1's power, a2's power, a3's power, right?
well, so, the powers must be a multiple of 3.
The power must be a multiple of 3 here, or a multiple of 2. See, if s squared,
I mean, if
s cubed equals a squared, right? So then they must be sharing the same prime factors,
okay,
right?
I mean, it must be a multiple of 2 since s is a perfect square.
Yeah, since a squared is a perfect square, so the p1, p2, p3, this, let's say do b1, b2. This is to prime factor s. This is to prime factor a, b2, b3, right? So that means if we do a squared, then this will be a squared will be p2b1, p2, 2b2, p3, 2b3, right? And then if we do the cube for s, this will be p1, 3a1, p2, 3a2, p3, 3a3, right? So then 3a1 must be equal to 2b1, right? 3a1 equal to 2b1. And 2b1 is an odd number or even number?
2b1 must be an even number.
Must be an even number, right? So that means 3a1 must be even. And because 3 is odd, so a must be even. So a must be even. So a1, a2, a3, they're all even numbers. So that said, s cubed must be some number to the power of 6, right?
Yeah.
So we can say s cubed equals a squared equals n. They must be say m to the power of to the 6th power. Okay, keep going.
Yeah. So then when you look at all of the cubes from 0 to 100, well, first you see that 1 cube would equal 1, which is probably too small.
Okay, 1 cube is 1 too small.
2 cubed is 8, which is also too small.
Too small.
And 3 cubed is 27.
Mm-hmm.
And 4 cubed is 64.
Mm-hmm.
But 5 cubed is 125, which is over 100. So then
so this is too big.
Yeah. So
and these two, they are not 2 digits. These are too small. So it's either 3 cube or 4 cube.
And then you look at 27. 27 is a cube, and 9 and 3 squared is 9. 2 plus 7 does equal 9.
Mm-hmm.
But for 64,
it doesn't work. So 10, 6 plus 4 is 10, right?
Yeah.
So it doesn't work.
Yeah.
Okay, good. So this is another idea. Good, right? Any questions about this problem?
Yes.
Go ahead, Kyle.
Is it possible for -3 cubed and -3 squared?
No, this is about positive numbers. Let me see what is
It doesn't
asking.
say that.
Oh, A is a 2-digit number. So negative is not really a 2-digit number. So there is a negative sign before it. So to be more specific, I should have made this problem a positive 2-digit number, right? Okay. Yeah, strictly speaking, it ought to be positive. Okay, good. Good question. Any other questions or comment? Okay. If no, let's move on to problem number 2. Well, this one, Kyle, you're actually one of the fastest to answer this one. Do you want to talk about this problem?
Yeah.
Okay, go ahead.
So if Dr. You were shifted to Leo's age, then Leo was also shifted that much to 9.
Okay, so that's it, that much. That much is the basically when
I'll
Leo
call
was
it
born, how old I was, right? So let's say when Leo was born, I was X years old. So you said when I shift to Leo's age, and Leo shift, that means shift to shift by X years, right? Okay, so Leo shifted by X as well. So that means what?
Leo goes to 9. Well, can I tell you how I drew this? So first, say 9, then L, then H, then 90.
9, Leo, myself, and 90. Okay.
So draw 2 arrows, one from H to L.
Okay.
And another from L to 9.
Okay.
And I called it Shift X. Well, negative X, actually. And then another arrow from Leo to H. And that was X, positive X. And H to 90 was also positive X.
Okay.
That means 90 minus 9 divided by 3 equals X.
Haha, very good. This is the answer to this question. So take a look at this, this chart. I love this chart, Kyle. Basically, if you arrange 9-year-olds, that's way back, when Leo was 9. Well, he is 9 now. And then Leo's current age, okay, and then Dr. Hong's current age, that's my current age, and then 90. So basically, when I was at Leo's age, if we shift my age to by X, okay, by X, Leo shifted by X as well, so that become 9 years old. Okay, so this is the first condition. So when Dr. Hong is at Leo's age, Leo was 9. Okay, and then the second condition was when Leo reached Dr. Hong's age. So Leo's age plus X, so Dr. Hong will plus X as well. So Dr. Hong is 90, right? If we look at these, that means between 9 and 90, there are totally 3 x's. 1x, 2x, 3x. Okay, the distance, these are equal distance, right? So that means if we do 90 minus 9 divided by 3, that's exactly what this distance is. That's 27. Okay? Good job, Kyle. Any other questions or comments or solutions? Hold on, let's see if there are other students giving another solution. Any other solutions? Or comments? I'll do a countdown. 3, 2, 1. Go ahead, Leo.
Well, at X was my age.
Okay, so hold on. Let me do this again since the notation is different. Okay, I'll start a new page. So Leo said what? L is your age.
I mean X.
X is Leo's age now. Okay.
And Y is your age.
Y is my age. This is also now. Okay.
Then that means when you're 90 years old, 90 years old equals x minus 9 plus y.
90 equals x minus 9 plus y, like this?
Yeah.
Why is that?
Because
90 equals x minus 9 plus y. Okay, tell me why.
Because x minus 9 is the difference between our ages.
Okay, so first of all, x minus 9 is difference between, basically it's the difference between x and y, right?
Yeah.
Okay, so then x minus 9 equals y minus x, right?
Yeah.
Okay.
So then if you add that to y, then it will become the your age when it's my when I'm your age.
I see. So basically this is the second condition, means this is saying when Leo reaches my age, I'll be 90 years old. So this is the difference, x minus 9 is a difference. And then plus my current age, that's 90 years old, okay?
Which means x plus y equals 99.
So this means x, if you move this 9 to the left-hand side of the equation, so 90 plus 9 equals x plus y. So x plus y equals 99, okay?
And then y minus x plus y, which is basically 2y minus x, also equals 90.
So say again, so y minus x plus what?
Y.
Plus y equals
90.
90. Okay, so this is because this x minus 9 also equals my y minus x, right? So you're putting substitute x minus 9 by y minus x, so that becomes this equation. Okay, this is, if we simplify this, this is what? 2y minus x is 90.
Yeah.
Okay.
And then I added those equations to get 30y equals 189.
You added these two equations. Add them.
Yeah, and negative y and that negative x and x cancel out.
So this is, yeah, x and negative x cancel out. This is 3y equals 189.
Yeah.
Okay, so y equals
63.
63.
And then x equals 36.
X equals, you can put it somewhere, you know, x plus y is 99. So x equal to 99 minus 63 is 36.
And you subtract 63 and 36, you get 27.
63 minus 36 is 27. Okay, this is the algebra way of doing this. Okay, very good. Cool. Any other questions or solutions? Okay, let's move on.
I have a question.
Another comment?
Yeah, I'm Connor.
Connor, go ahead.
So when you got the equation x minus 9 equals y minus x, y is Dr. Hong's age now. And if you cancel out x and negative x,
You cannot cancel this, right? Left side is x minus 9. The other side is y minus x. You cannot cancel x.
I know, what, why though? Why can't you cancel x?
So see, one side is x minus 9. The other side is y minus x. Let's say you want to move, you know, cancel the x on the right-hand side. You have to plus x on both sides, right?
Oh.
So then that becomes 2x minus 9 equals y. So you can never cancel the plus and minus x on two sides of the equation.
Oh.
Right? Okay, let's move on to the next one. Olivia, let's go with your solution about the third problem. Okay. Well, this one is tough. This is actually I don't know if your parents told you. This is a research problem in graduate school. If you go to graduate school, and if you study operations research or industrial engineering or some of these discrete math majors, then you'll encounter this. This is called traveling salesman problem. Traveling salesman problem. It's about a salesman trying to travel from one city to another, and trying to move among many cities and go to each city once and then go back. What's the shortest path? Okay, let's hear from Olivia.
Okay, so I pulled up Google Maps.
Okay. You want me to go to Google Maps?
I drew it down, but you can go to it.
Okay. So this is a Google Map.
And then I found that the shortest route would be from Charlotte to Columbia.
So Charlotte to Columbia.
And then,
Columbia is somewhere in the middle.
yeah, and then Myrtle Beach.
Oh, hold on. Somehow. How about let me draw these cities? Okay, so we know Charlotte, Columbia somewhere in the middle, and Myrtle Beach. Let me draw this picture. Okay, I'll draw this picture. No, it doesn't project. Okay, let me draw this picture. So there's Charlotte, okay, and then Columbia is somewhere here. Columbia, all right, and then Myrtle Beach.
And then Charleston.
Charleston is below Myrtle Beach. Charleston, and then Savannah, and then Atlanta.
Jacksonville.
Oh, Jacksonville, yeah, along this line. Jacksonville,
And then
Orlando. Okay, I'll just and Orlando. Okay.
Then Tallahassee.
And Tallahassee. And then
Atlanta.
Greenville is somewhere on the top, right?
Yeah.
Greenville.
And finally Spartanburg.
Okay, so that's your path. Charlotte to Columbia to Myrtle Beach to Charleston to Savannah to Jacksonville to Orlando, and then go back to Tallahassee, Atlanta, Greenville, Spartanburg, and back to Charlotte, right?
So then I found the shortest route between each city.
You calculate the route between each city and then add them up, right?
Yeah.
I think that's around 1,500, 14 something, right?
Mm-hmm.
Okay. So how did you find this route?
Because I knew that it would take longer if you made detours, so you had to go in a circle.
So this is important, right? So you say you have to go along a circle. So in other words, if we have a few dots here and we want to connect these dots, okay, the shortest path, right? If you don't go around a circle, if you do, let's say, from here to here, and then back there to here, and then here, and here, and then here, because of this, you have to walk longer than necessary, right? So you have to try to find a circle, right? Any other clues when you figure out this shortest path?
I just had something I wanted to say.
Let's see if Olivia finished. Olivia, anything else to add?
No, that's it.
Okay. Then there was a comment from someone.
It was me,
Connor. Okay, go ahead.
Yeah. So what I said was if Google Maps, you don't really have to figure out the whole how long it takes from Charlotte to Columbia and then Columbia to Myrtle Beach. I think what you can do is it just lets you go from Charlotte to Columbia. It like has a feature where like it just lets you go from one city to another and go between a bunch of cities, so you can find.
I think that Connor, thank you. That's a great great comment. Google Map, there's a feature you can add multiple cities, right? So you can add multiple cities to your route, but the problem is I think they only give you 10 cities.
And I also think it doesn't always do the quickest.
Yeah. So one thing is it only give you 10 cities, and I give you 11 cities. There are 11 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are totally 11 cities here. So I don't think Google Map can give you the whole route. Another thing is, when you type in multiple cities on Google Map, I think there's an algorithm may automatically give you the quickest way. It may not give you the shortest path, because sometimes there may be congestion, there may be traffic somewhere, so there will be detours here and there. So that's what Google Map give you. It doesn't tell you what's the shortest path if you input too many cities.
Yeah.
But that's a good observation, Connor.
Thank you.
Any other comments on this problem? Okay, you need to finish in 1 minute. Go ahead.
Well, another small clue is that, I think that, Columbia is a little bit above Myrtle Beach.
Okay, Columbia is above Myrtle Beach. So you don't go to Myrtle Beach and then go back to Columbia.
Yeah.
Okay, good. Any other thoughts on this? Well, my first one, when I look at this, my first route was from Charlotte to Spartanburg to Greenville and then Columbia and then Atlanta, go this route. Okay, and then I started comparing if it's going to Columbia on the left half, or going through Columbia on the right half. In other words, should I put Columbia after Greenville or should I put Columbia before Myrtle Beach? Okay, so that was a decision point to figure out which one is shorter. So, but beyond that, it's trying to make a circle. That's what Olivia said. That's the shortest path for this problem. Okay, this is a relatively easier problem among the family of these traveling salesman problems. There are other variants. If I gave you things that these thoughts are fairly random, then it may be hard to figure out where to go and which is the short path. But this is an interesting problem too, because in the future, when your family goes on a field trip, you can be the trip planner, right? You can plan for the shortest path.
But you also need to plan for the one that takes the least time.
Yeah, of course. Yeah, you need to look for the time as well. So in this case, I'm only minimizing miles. So in the future, you may be minimizing the minutes. Okay.
Or the time.
Excuse me.
Yeah, go ahead.
I have a problem. I have a question here.
What's your name? By the way, next time you need to put your name on the chat box. Put your name instead of number 1. Okay.
Isaac. That's Isaac.
Okay. Go ahead.
Okay.
What's your name?
Isaac.
Okay.
Can't you go from Charlotte, Spartanburg, and then go around and then come back from Columbia to Charlotte?
Yeah, you can do the other route too. So Charlotte, Spartanburg, and Greenville, and then come back. This is actually one of the things Leo was trying to. So he figured when you're going there, if let's say from between Charlotte and Spartanburg, going Charlotte to Spartanburg, the distance is different from Spartanburg to Charlotte. Okay, so then there are probably a couple miles of difference. Then you can figure out which way is either clockwise or counterclockwise. One of them is shorter. Good comments, Isaac. Any other comments? Okay, if no other comments, give me a thumb up before I turn this off. You all good?